In this video, we're going to talk about two important theorems. The mean value theorem is the most applicable because it works for any slope. Rolle's theorem only works when the slope is zero. But they have almost the same conditions. Rolle's theorem has this extra condition that the y values must be the same. And what that does is that creates a slope of zero. Mean value theorem doesn't have that condition, so it actually works for any slope. But they basically say the same thing. So as long as the function is both continuous and differentiable, there has to be at least one point in which my derivative equals zero. And again, that's because of this condition here that the slope must be zero. The mean value theorem is again more applicable because it says my derivative has to equal the slope. So you got to find the slope. It's not always going to be zero. But basically, if we were to find 2 points on an interval, if we were to calculate the average rate of change, again, which is just the slope between these 2 points, what this theorem says is that somewhere in this interval on this function, there is a point at which the tangent line must be exactly parallel. And so what that means is our instantaneous rate of change, which is our derivative, that gives me the slope of the tangent line. It says the derivative has to be exactly the same as the slope at least once in the interval. So we can kind of think of like driving on a freeway. If I were to calculate my average speed, let's say to be 71 miles per hour, the theorem just says there has to be a point in which I was actually driving 71 miles per hour. At least once. Obviously your speed would fluctuate, but there has to be at least once when your actual speed was the same as your average speed. And the way we do this is we just find the derivative and we set it equal to the slope. So first we're going to use Rolle's theorem. The only difference in Rolle's theorem is that my slope must be zero. Okay, and the way we guarantee that is that f of a has to equal f of b. So those are my conditions. So first I need to check to see if this guy is continuous. And we know he's continuous because he's a polynomial. Secondly, we need to know that it's differentiable. And we know that because if we take our derivative here, we get a polynomial, which again is always differentiable. The last condition we have to make sure is that f of a equals f of b. And so that just says we're going to plug in our 2 endpoints to our original function. So f of -2, we're going to take that to the 4th power, and we're going to continue plugging that in to our function here. So we'll get 16. Here we'll get 4 times -2, and we'll get a value of 8. If I did the same thing with my final endpoint, I'll get 2 to the 4th minus 2 times 2 to the 2nd, which is still positive 8. Because these are exactly the same, that means my slope is 0. And that was the 3rd condition. So these two theorems both say, take your derivative and set it equal to our slope. Well, our slope in Rolle's theorem is 0. So it's just a very specific case of this. And the theorem just says, when we solve this, we have to get at least one answer in this interval. We have to. So if you don't, then you know you messed up. But anyway, so we're going to factor out a 4x, and we'll get x squared minus 1. If we finish this here, we get a solution of 0. And if we set this guy equal to 0, we'll get a solution of plus or minus 1. In this case, all 3 of those are in this interval. So all 3 of those are those specific c values that we're looking for that fall in our interval. Now we're going to look at a more generic version, and this is going to be mean value theorem. So again, we do have to meet our conditions, and this just says determine whether or not we can apply this. So first of all, it has to be continuous on the interval. And the way we check that is to set the denominator equal to 0. When we do that, in this case, we're going to get x equals -1. So that means this is not continuous at -1. And since that's part of my interval, it does not meet that requirement. So we just say the mean value theorem cannot be applied because the function is not continuous on that entire interval. So it's continuous everywhere else, just not right here at -1. So if we have to pick up our pencil the theorem's now out the window. It could do whatever it wanted to. So our last example here, again, we're going to do the same thing. We're just going to first determine if we can use this theorem. First, we must determine whether or not it's continuous. And yes, it is, because that's a polynomial. Then we have to make sure that it is differentiable on the interval. And when we find our derivative here, we're going to get 3x squared minus 7, which is still a polynomial. It exists everywhere. And those are the only two conditions for mean value theorem. And now what we have to do is we have to take our slope and set it equal to our derivative. And we're going to get some answer that has to be in this interval. So we have our derivative already. Let's find our slope. We need two y values. So we're going to plug in 1 and 3. So f of 1, we're going to get 1 minus 7 plus 6, or negative 6 plus 6 is 0. And now we're going to plug in 3, and we're going to get 27 minus 21 plus 6, and we're 12. So when we find our slope is going to be our y value minus our other y value, all over x minus x. And we get 12 over 2, or slope of 6. And then the theorem says, let's go ahead and set these equal to one another. And so we're going to get 3x squared minus 7 equals 6. And we're going to solve. And we have to get at least one answer in this interval. So we're going to add 7. So 3x squared equals 13. We're going to divide by 3. And we get x squared equals 13 over 3. Finally, we're going to take our square root. So we'll get x equals plus or minus the square root of 13 over 3, which is like 2 point something. So we got two answers, a positive and a negative. Our interval in this case was 1 to 3. And so only one of these values is on this interval, and that's going to be our positive one. So we say our c, which is just our specific x value, is going to be positive radical 13 over 3. So even though there's two places this happens, the mean value theorem says it has to happen at least once in this interval, and it does right there.